Hello, this is Dr. Sreekanth, Professor, Department of Data Science, Institute of Aeronautical Engineering. In yesterday's session, we completed the logical connectives and the duality concepts we completed. Now, in this session, we are going to concentrate on converse, inverse, and contrapositive. See, whenever if you are going to consider a compound proposition, let us say the conditional, if P then Q, if P then Q, then for that, this is a conditional. For this conditional, we are going to write what is converse, what is inverse, and what is contrapositive. See, for the given conditional, if P then Q, then if I am going to take, if we are going to consider, if Q then P is called the converse of the conditional if P then Q. And if we consider the negation of P, if negation of P then negation of Q is called inverse of if P then Q, and negation of Q then negation of P is called contrapositive of if P then Q. So for any conditional if P then Q, we are writing the converse, inverse, and contrapositive. So these are the concepts for the given conditional, any compound proposition which will be there, then we are going to mention like this. And now these converse, inverse, contrapositive, and conditionals are equivalent to each other. See, if we are considering the conditional and contrapositive, so then if we are going to consider these two, conditional and contrapositive, both are logically equivalent. That means if you are going to consider the truth table for this, they are going to same. And if the conditional and the inverse, conditional and inverse are logically equivalent. So now we are going to concentrate some of the problems which are related to these concepts. Now, we are considering one example. Let us say P is the proposition, or it is 2 is an integer, and Q is another proposition, 9 is a multiple of 3. Then the conditional if P then Q can be taken as if 2 is an integer, then 9 is a multiple of 3. Now we are going to write the converse of this conditional. The converse is if Q then P. So that is nothing but 9 is a multiple. If 9 is a multiple of 3, then 2 is an integer. Then the inverse of the conditional can be taken as if negation of P, then negation of Q. That is, we are taking if 2 is not a, see here negation of P means if 2 is an integer, negation of P is nothing but if 2 is not an integer, then 9 is not multiple of 3. Then its contrapositive is negation Q, then negation P. That is, if 9 is not multiple of 3, then 2 is not an integer. So these are some example, one of the example. So how we are going to convert the sentences into converse, inverse, and contrapositives. Now let us consider a truth table. So we are going to say that the conditional if P then Q, and which is equivalent to negation P or Q. So both are equivalent. We are saying that equivalent. So then the negation, we are going to consider the negation of this conditional is negation of, see here, negation of negation P or Q, which is equivalently taken as sending negation inside, then double negation of P, which is nothing but P is itself, and negation of R, it will become and, then negation of Q, negation of Q. So this is a P and the negation of q. So the negation, we are taking this and it will become this size. So now we are going to verify the conditional and its negation. So for that, first negation of P, then Q. So for that, the truth table, and the next for this, the truth table. Suppose if these two are equivalent, then we can say that, then values are equivalent, then we can say that both are equivalent to each other. See, last one is, if we are taking the last one, so what is this? Negation of P. If P then Q, then it's inverse. See here, this is another one is the conditional and the converse and the inverse of a conditional. Converse and inverse are the logically equivalent. So now we just simply taking this, any conditional, if I am taking this, and then we are taking its negation. It's a negation showing that both are equivalents. So for constructing the truth table for this, so all the truth values, let us say this is false, and P then Q were calculated, then false is true, and false true is true, and the next true false is false, and true is true. Then the negation, if you are considering the opposite, we are going to get, then negation Q, then is nothing but this is a P and negation Q. P is this and negation Q is this. True and true. So true and negation of, so this is a P, P is a false and the negation of Q is true. So this is false. And the next another one is P is false and negation of Q is false. So which is false. And the next another one is true and the negation of Q, which is also true, implies it is true. And the next another one is a negation of it is true and then it is false. So it will become false. So here the whenever we are taking any conditional, then the negation if you are taking on both sides, then also it is a equivalent. Now some of the examples, another one more examples. Let us say X is a specified real number, write the negation of the condition. So if X is an integer, then negation X is a rational number, then X is a rational number. So one is X is an integer is a one type of sentence, another is X is a rational number. So for that we are taking, if P is a statement, P as X is integer, Q as X is a rational number, then we are going to take this given sentence as if P then Q. Then we are taking the negation for that. So negation is, so negation of this, which is equal to negation of this, which is equals to negation of negation P or Q. So which is equals to P and negation Q, which is earlier we solved. So this is nothing but this. So both are logically equivalent. Then we can say that according to this, the negation of this is this. So we are going to use this. See what is this? If X is an integer and X is not a rational number. So negation of this conditional by using this concept, and we are going to write in words. So let us take the other one. If X is a specified number, write down the negation of this. So here, if X is not a real number, then it is not a rational number and not irrational number. See here, one is real number will be there, and another one is rational number will be there, and another one is a irrational number will be there. So we are going to write this as a combination of three prepositions. One is a P, another one is a Q, another one is R. So P we are taking it as it's a real number, and Q we are considering it as a rational number, X is a rational number, and R we are considering it as a X is irrational number. Not in this order. Any order we can consider the prepositions. Directly you can take negation also. But our consideration, with our consideration, whatever the given prepositions are considering, based on that, how the compound preposition will be. That is the main aspect. So here, the statement is given in this form, and the symbolic form, we are going to write this as, see, we are taking it as, if X is not a real number, so P is what? If X is a real number, so we are taking it as negation P. Negation P. So then will be there. So we are taking this as the conditional. This as the conditional. And then it is not a rational number. So negation of Q. And not a rational number. Negation of R. And negation of R. So we are taking just a negation of the whole thing we are going to consider. So negation of whole thing means we took negation. We took negation of this. Once again, we are going to use the same concept. What it is, if P then Q. If P then Q is equivalent to negation P or Q. Negation P or Q. So this we are considering it as, this is equals to negation of negation P, negation of negation P, this one, or then negation of Q and negation of R. Negation of R. So for whole thing we took negation out. Whole thing we took negation out. So then this will become negation of P. Double negation will be P alone, and a negation of R, it will be and negation of negation Q, it will be Q, R, and a negation of this is and will become, so this is and will become R, then negation of R, it will become only R. It will become only R. So that we are going to represent. The finally, the next one, let us say in the next, see this is, now see this is, see last one is, this we are considering, this is in this form, just sending, we are going to rewrite that, this is P and, negation P and, see here, this is, I'm not sending inside, next step, negation we are going to sending inside, so that will become, negation if you are going to sending inside by using De Morgan's law, then this will become like this. This will become like this. So now based on this, we are going to write in a sentence form. So first one is negation of P. Then X is not a real number and X is a rational number or X is an irrational number. So whenever the statements, if you are going to take a negative or negation of the given statement will be there, which is represented in English language, better to convert into the symbolic form, then apply negation and convert to its equivalent form, then write in sentence. That is the way that we are going to do whenever if you are going to write any negation of a symbolic negation of an English sentence, that can be write first symbolic form, and after that you take the after that you convert into the equivalent form, or for equivalent reduced form you apply the negation. See here it is given some of the problems. See, similar concepts will be there. So if I dream of home, then I will work hard and earn money. See, here we took the compound preposition as P is I dream of home. Then Q will be I will work hard. And R is I will earn money. Then the first one, based on these assumptions, then this will become if P, then, and I will work hard, Q, and earn money. So this is the way. So this we are going to get in a symbolic form. Rewrite the sentence without using the conditional, here. So here it is used as condition. Now I am taking the equivalent form of this. Negation of P, R, then Q and R. So this is the conditional. What is the equivalence of the conditional? Which is equivalent to negation P, R, Q. Negation P, R, Q. So based on that, so I just apply the conditional concept and I remove the conditional. So subsequently, see what is the given thing is rewrite the following sentences without using conditional. So this is the final answer. So based on this, like that, we can do the remaining things. All are using this concept only. So similarly, if I awake, then Q as considered as another one. Q will be taken as like this. Let us take, I will work on computer. And next another one is R, I read the novel. So now based on this, so P is if I am awake. I am awake. Q is I will work on computer. R is I am reading the novel. So based on this, once again this will become if P, then Q, R, R. So once again we have to apply the same formula. So this is negation P, R, Q, R, R. So like this. So if you want to connect this, convert it, this is a symbolic form. If you want to write in a sentence form, then if I am not awake, if I am not awake, there is no if. I am not awake, or I will work on computer, or read the novel, like that. So similarly, you can do the third one also. See, if I study mathematics and discrete structures, then I will not fail in the examination. See here, one is if I study mathematics, P. If I study mathematics, P. Then another one is P I am taking. This is P. If I study discrete mathematics, I will study discrete structures. Then the next one is I will fail in the. I am not considering not. If you want, you can consider, no problem. It's not at all a problem. You can consider I will not fail in the examination. Let it be taken as R. Then see here the conditional if P and Q. If P and Q, then R. So like this. Or then I can take it as equivalence form, then negation of P and Q, or R. So the English sentence is once again, if I am not study mathematics, this equivalently I can write this as negation P, R negation Q, R, 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 R. So, I will not study mathematics, or I will not study discrete structures, or I will fail in the examination. I will fail in the examination. Like that, we can convert. We can convert into the sentences. Now, let us consider two more logical connectives. One is NAND and another one is NOR. See here, NAND means negation of AND. NAND means negation of AND. Negation of AND. See here, any two prepositions if you are going to consider P and Q, then P and Q, P and Q and operation. So for that we took negation. Either we can use this symbol or else we can use this symbol. Both are same. So this is known as P NAND Q. This is known as P NAND Q. So like that, this is similarly NOR, which is a negation of R. So similarly, this can be written as, so it is a negation of PRQ, which is NOR. Now let us concentrate how to construct the truth table for this. One is NAND, another for is NOR. So P and Q, for that negation we took. So here P and Q is true and its negation is false. True and false, which is false, its negation is true. False and true is false, its negation is true. Then false is false, its negation is true. Similarly here, R, if I am considering true or true, it will be true, then its negation is false. Similarly, true or false, which is true, but its negation is false. And false or true, it is true, but its negation is false. True, false or false, it is false, but its negation is true. So, NAND NOR is nothing but negation of P and Q. NOR is nothing but negation of P or Q. Now, there are for any simple things. So, we have to prove this by considering P NAND, Q NAND, R. Let us say for this. We are going to concentrate. The first one is, let us say, I am just removing this. So, which is equivalent to P NAND. What about this Q and R? Negation of Q and R. NAND I applied. So now once again this is P and this is Q. Once again negation of P and negation of Q and R. So once again sending negation inside, then it will become negation P, R, negation, Q and R. So which is equivalent to negation P, R, Q and R. So this is here. Negation P, R, Q and R. And similarly, we can prove the remaining also. Suppose NOR will be there. Let us say this is the next one is. Suppose this we have to consider. So first I am taking negation of P and Q. NAND R. So which is equals to, once again apply the same thing. Double negation P and Q and R. Negation of like this and R. Now this will send negation inside, negation P and R. So double negation inside, so it is a double negation P and Q, and negation of and will become R, negation of R. So this will become P and Q, R, negation of R. So this is this. Suppose if you are going to concentrate on this one, so NOR operation, so it is a P, NOR, then this will become negation of Q, R. Once again this will become negation of P, R, negation of Q, R. So this will become negation of P and double negation Q, R. So which is negation of P and Q, R. Which is this. So like that the equivalence forms we are going to write, and that means NAND and NOR symbols we are going to convert it into NAND or negation. In equivalent way, we are converting and we are going to find, we are going to construct the truth values or equivalence values we are going to construct. Now, let us consider the another important concept, which has normal forms. See, normal forms, why it is used? How many types of normal forms will be there? So this is also for testing. See here, let us consider P of x1, x2 and so on, which is consisting xn statements. The compound proportion is consisting n statements. To determine whether P is a tautology or contradiction, for that, by constructing a truth table, it is very difficult because we are going to get 2 to the power of n combinations. So it is very tedious. So for that reason, and we are going to go for the normal forms, which the main intention is whether the given compound proportion is a tautology or a contradiction. So to achieve this task in a simpler way, express the given compound form, compound proportion, which is in normal form. Decide P is a normal, is a tautology or contradiction based on the following results. An elementary product is identically false if it contains at least one pair of factors, in which one factor is its negation of the other factor. So here, if it is false, means suppose if I am taking P, Q, R are the three statements. Suppose if I am getting one pair of factors which one factor is a negation of the other. Suppose if I am taking P, let us take P, and negation of P if I am going to get, then this is false. This is equivalent to false. Suppose P, Q are any three statements. Let us say I am going to get, let us say, P elementary product. So that means P R negation P or anything if I am going to get like this. P R negation P R Q, let us say, and negation of P R Q. Suppose if I am going to get like this. So this is true and negation of also true, which is a false, which is a contradiction. Next, an elementary sum is identically true if it contains at least one pair of factors which one factor is its negation of the other. Suppose if I am taking P R negation P, if I am getting P R negation P, then it is true. So in the same way, instead of this, if I am taking sum, then this will be true. So tautology, if the reduced forms, as this mentioned, either this one or this one, if it is there like this, then we can say that it is a contradiction. Otherwise, it is a tautology. Now, what is the meaning of sum and product? Simply we say that, see here, the product we are written here, the sum we are written here. What is the meaning of this? So simply sum and a product. See, the sum is nothing but place the conjunction and sum in place of disjunction. For convenience, we use the word product. Where product is whenever and will be there. So I am saying that P and Q. P and Q. The two preposition, in these two preposition, there will be a conjunction. So I can call this as a P and Q, product of PQ, product of PQ. If I am taking P or Q, then it is a sum of PQ, sum of PQ. Suppose if I consider any three prepositions are there, let us say P, and right now I am just concentrating only up to this. Afterwards, we are going to go for the next one, next level. So the meaning of sum and product is, product means and will be there, then we are going to call it as a product of P and Q. Sum will be there, P or Q, can call it as a sum. Now, elementary product. So this is simply product, and now we are calling it as elementary product. See, elementary product means a product of variables and their negation in a statement is called elementary product. A product of variables and their negations, Product of variables. Suppose 2 and 2. P and Q are any two prepositions. Then P and Q is the elementary product. Or P and negation Q is the elementary product. P and negation Q. Negation P and Q is the elementary product. So like that we can call all these are all elementary products. P and Q and R. P and Q and negation Q are elementary products. What are the elementary sum? So there are any number of terms that we are going to use as the prepositions. So 3 times we can take, 4 times we can take, or any number of times. P or Q or negation P or negation Q. Also you can write it as elementary sum. Elementary sum. So if we are considering this is elementary sum or elementary product, this is elementary sum and this is elementary product. Let us consider in that we are taking the P and Q. We are calling it as a factors. Factors, elementary factors. Factors simply we can call it as. So P and Q are a part of the elementary sum or product is called a factor. So here P is one factor and Q is another factor. Now so far we are not going to discuss what is normal forms. Normal forms are broadly classified as 4 ways. One is a disjunctive normal form, conjunctive normal form, and principal disjunctive normal form, principal conjunctive normal form. Now we are concentrating one after the other. So elementary products we are considering, elementary sums we are considering. Now we are going to define what is a disjunctive normal form. What is a disjunctive normal form? A compound form is said to be disjunctive normal form or a statement formula which is equivalent to express as the sum of the products. We can say that elementary products, strictly speaking, sum of the elementary products is called a disjunctive normal form. Any compound preposition which will be converted in the form of sum of elementary products, then that is in disjunctive normal form. See, now we are going to take down some examples and how we are going to convert its disjunctive normal form. So here the procedure. So if it is given the compound preposition which is consisting n statements. Now we have to remove conditional and biconditional. wherever in the compound prepositions are exist, we are going to remove the conditional and biconditional. In that place, we are going to replace and or negation. And or negation. Once if you are going to replace and or negation, then after that, for that we are going to use so many distributive laws or associative laws or De Morgan's laws or whatever it is. And we are going to reduce into the applying so many times of these formulas, and we are going to reduce to another form. That reduced form is whatever we said earlier. That is nothing but the sum of the elementary products. Then we can say that is in disjunctive normal form. Otherwise, it is not in a disjunctive normal form. So these are the procedure to construct the disjunctive normal form. Now let us consider. See here, this is one compound preposition. See, observe the compound preposition will have a conditional. So the conditional we are going to replace its equivalence form. So for this is the equivalent form. So we just remove the conditional. Once we are going to remove the conditional and apply distributive laws or De Morgan's laws or any other kind of rules of logic, we are going to apply and we are going to reduce. See here, P and, I am just applying distributive law. So then this is going to be written as P and negation P or P and Q. See here, this is a product, elementary product. This is another elementary product. See, what is the previous one? What we say that this is the sum of elementary products. Now here, this is one elementary product. This is another elementary product. And R will be there. This is a sum of elementary product. So we can say that this is in normal form. This is in disjunctive normal form. So we have to specify what type of normal form it is. We are just concentrating first disjunctive normal form, afterwards conjunctive normal form. Okay. Now let us say this is the another example. So first of all, we have to remove wherever the conditionals are exist. See here, the first one is, so if Q then R, the equivalent form of this is negation Q R R. So now another one is P2 Q2 R. So this we are taking it as this is equivalent of this. So if P then negation Q R R. So once again we are just to take it as once again equivalent form, negation P or negation Q R R. So we simply apply, the negation is outside, so apply negation of the whole. So which will become negation, double negation of P. It is, see here, we just took this is negation P or this is negation Q R. So simply we are going to sending inside, then this will become double negation is a P and then this is a negation and a negation Q R R. So then this will become P and Q and negation R. P and Q and negation R. See, this is Q and so they by using this formula. So what we are going to get negation. So we are going to get P and Q and R. P and Q and R we are going to get like this. So this is taking negation of negation P R. Sorry, this is Q and R. It's not, this is only one conditional will be there. It is not twice. We are not going to take any two conditionals. It is simply if Q, if P, then Q and R, then Q and R. So for that, negation P, R, Q and R. So once again, going negation inside, then double negation of P, R will become AND, then negation of Q and R. So this is a P and it will become, this will become like this. Now applying distributive property. So P and negation Q, R, P and negation R. So this is the product. This is the elementary product. This is the product of the variable. So this is the sum of the products of the variable. Sum of the products of the sum of the products. So this is in the disjunctive normal form. So here there is no conditional. It is simply AND. Now let us take the other one. See, this is the, let us up to here. Now if P, first remove the conditional which is there inside, which is there first here. I am going to remove this. So then that is equivalently written as this is negation P R Q. The remaining we won't disturb, and next I am just simply double negation sending negation inside. So it will become like that. So I just simply simplify this. Double negation Q is Q and this is reduced to this and this is same as it is. Now if P, now I am going to concentrate on this. Remove this. Negation P R, the whole thing. So now negation P will be the same, and now apply this. Negation P and this. Next R, Q and this. See, negation P and applying distributive property, and we are going to get this. R, Q and this. Next, simply AND will be there everywhere. So just we are going to remove the braces and we are going to get like this. And here Q and Q, which will be Q. So in the place of two Qs, I took only one Q. And apply commutative law. Apply commutative law. Wherever, if you are interested, you apply commutative law. Otherwise, the same as it is also you can consider. Then this will become negation P R. Next, negation Q and negation P and Q and R. So the reduced one is nothing but the sum of the products. Sum of the products. So it is in disjunctive normal form. Which is in disjunctive normal form. So like this, whatever the given compound proportion will be reduced to in this particular form, then we can say that by observing the reduced form, we can say that for this given compound proportion, this is the disjunctive normal form. This is the disjunctive normal form. Let us now the other concept. Conjunctive normal form. Conjunctive normal form. See, this is earlier one is sum of the elementary products. Now completely opposite to this. It's nothing but a dual of that. Nothing but a dual of that. So element is a product of elementary sums. A statement formula which is equivalent to the given and consists of product of elementary sums is called conjunctive normal form. Is called conjunctive normal form. So we are just taking the same. Suppose we are going to, for this expression, we are finding the conjunctive normal form. The conjunctive normal form. So for that, once again remove this, the same procedure, negation P R Q. So this is one sum, or I can write it as, if you want to write, I can write like this, P R P and negation P R Q. So this is nothing but product of sums, product of elementary sum. So which is, instead of writing this, we can say simply this is also in a conjunctive normal form. Conjunctive normal form. So the next another one is negation of P, if P then Q and R. So once again concentrating on this. So that is negation P, R, Q and R. Negation P, R, Q and R. Then sending negation inside, then this will become like this. This will become like this. Negation inside and R will become AND. R will become AND. Then double negation is a P and negation Q or R. Once again, see here, this is a elementary sum. And this I can write it as once again in the same way like this. P or P. And negation Q or negation R. So, this is in the conjunctive normal form. Consider the next one. So, if Q then P, negation Q or P. And this is not going to be disturbed. And this is only changed. That is conditional is removed. And apply, just applying commutative principle, then I am going to get this. And same as it is. Then we can apply then distributive first you observe this. This is negation P. This is the sum. But this one is not the product of this thing. So this is, we can consider. So these some more steps we have to perform on this. Negation of P and P or negation of Q. Negation of Q. Then this will become, or else I can consider it as some more. This is PR negation Q and negation P. Next, or else I will take in this order. So see that in which way we are going to consider. We are going to get the P and negation P and negation Q. R, this is this. Then R, negation Q and negation P and negation Q. So once again this is going to be reduced. So P and negation P, R, P and negation P. Okay. Anyhow, these are all, this will be there. Then we are going to consider it as P and negation P and negation Q. R, see here, concentrate on this. Everywhere negation will be there. So I can write it as negation Q and negation P and negation Q. See, this is the product and the sum of the products. This is not in, because here AND will be there. So it is not elementary sum. So this is going to be reduced to this form. Then this is the sum of the elementary products. Sum of the elementary products. Okay. So this is in conjunctive normal form. Conjunctive normal form. Let us concentrate the another one. If P, then P and Q to P. So first concentrate on this. So which is equivalent to this. Next concentrate on this. On this. So negation P are the same. Are the same. So now negation P are, then we are going to simplify that. But that means by applying distributive property. So first of all, P and Q, then P and P. So apply the like this, then we are going to get these two results. Then afterwards, PR, then PRP, then once again, so we are just taking P and so P, this is R will be there, then apply once again PRP, then and PRP. Similarly, QRP and QRP. So applying individually for this and for this distributive loss. And afterwards, we just apply negation P here. So negation P, and we are going to get like this. This is the expression. This is the expression. So negation P, R, P and Q. Okay. This is one. And another one is, next another one is negation P, and this is the second one. And this is operates on this, third one. The whole thing operates on this. This is the fourth one. Now here it is somehow, it is a repeated will be there. This term and this term are same, and this term and this term are same. So instead of taking two operations, we can consider only one, or else the same thing is in conjunctive normal form, or reduce the given form into another form which is also in the conjunctive normal form. So far we discussed disjunctive normal form and conjunctive normal form. Now we are going to discuss what is the principal disjunctive normal form and principal conjunctive normal form. Principal disjunctive normal form and principal conjunctive normal form.
Like, share and subscribe. Hit the bell icon for more updates.